Boom. Well, good morning from Knoxville, Tennessee. Election day, baby. I've never heard anybody talk more about elections in my life than they've been talking about this election. So I would just say go out and vote. And I don't know how you're feeling about it, but I know how I'm feeling about it. And I'm going to talk about it here in just a second when I pray about this, and then we get started into our stuff. So I'm going to say a short prayer here, and then we're going to get started. All right? Father, thank you so much for today, for Election Day here in our country. And no matter what happens, Father, I know that you're in control of things. And Father, as a Christian, I put my faith in the ruler of eternity and not a term. So, Father, I am putting just my faith in you. I know that whichever way this comes out, you're in control. So I'm going to be good either way. I'm going to be like the rest of us Christians and may not be the person that we particularly wanted, but we're just going to go to work the next day and put our faith in you. So, Father, thank you so much for this day, for the opportunity for us to even vote and to have a country that we can actually freely vote. And we lift the decision up to you. And thank you so much for this day and another chance to come down here and maybe show someone something that can help them out in the field, not only do their job better, but maybe do it safer, which is the most important thing. So all of these things we ask and say according to the will of the one who paid it all, my brother, Jesus Christ. Amen.
Amen.
All right, let's do it. Okay, so today it's which probe do I use? So we're going to be talking about, there's several probes that we have. They're a part of the lineup for Powermetrix. We're going to talk about them individually, talk about choices you can make and different options that you have, because a lot of times when we go out there, we know all these installations are different, right? So you'll go out there, and we have a lot of utilities that don't have test switches. We have some that they test their self-contains out in the field, and some bring them in the shop. Everyone's different, but you have to have a full line of these accessories and these probes to be able to test all these different meters, and it makes it a lot more convenient for you in the field to do it using these different type of probes as well. And we're going to talk about all that. So we are in Series 15. It just blows my mind. But we're in Series 15 on the Quarantine Webinar Series. And so we're going to talk about probes today, as we said. Chris will let me know what we're going to be talking about next week. But right now, today, we will talk about probes. So here's the agenda for today. Chris has got some information he's going to go over, and then I'm going to actually do the hands-on stuff, show you the probes and show you some different little tricks with them and actually use the probes, put them in action. Chris is going to talk about current and voltage probes, which one is correct for that application, which one might be easier, some easier ways to test some certain installations and applications, because there may be distances and different things involved. So Chris is going to talk about that, and then I'm going to actually show you live here different ways using these probes, okay? So, me or you?
Yeah.
Oh, okay.
I'll pipe in.
You'll pipe in. Okay, so normal operating procedures. Okay,
Yeah.
Got it. Yeah, which I like. I love it when you pop in. All right, so let's talk about the probe. So we got, here you're looking at current probes, so we're going to look at some secondary ones first of all. So you can see these are all for less than 600 volts. Okay, so we've got the MN375s over there on the left. They're rated for 10 amps. And then the ones on the right are our newer ones, the MN114s. They're also rated for 10 amps. Okay, so I would say that for me personally, I like the MN114s. I think they're smaller, they're easier to get in there. As long as you can get around the conductor, it's a little bit smaller aperture than over there on those 375s, but not much. But if I can use the MN114s, I like their accuracy a little bit better, and also they're just so much easier to get up in the tight cans. Okay.
Yeah, I agree, John. I've had a lot of success with those, especially they're very good avoiding any kind of electromagnetic fields.
Right, absolutely. Yeah, they seem to have more protection than the 75s.
Yeah,
that's right. Okay. Then we've got also for the 200 amp max. So now when you're talking about the self-contains, right, and we're talking about 2S's, we of course are going over the 10 amps, right, that's available there, the current. So we go with our MN353s. Those go up to 200 amp max. So those are ideal for using on 2S's. Okay, so you can use those MN353s. They are actually, if you noticed a second ago, I'm going to pop backwards. they're actually the same size as the 375. So they're good and convenient. They're small, got a little smaller aperture, but they're easier to get in the cans. But they are rated all the way up to 200 amps. So that means we can get up into the self-contained stuff in 2S's with those, all right?
Yeah, for those customers that actually have both the 375 and the 353, just be careful.
That's right.
And look at the label before you clamp around.
That's right.
Because if
Mark
you're
them
clamping on
somehow.
200 amps on a 10 amp probe, you may see a little.
Yeah, you may. Yeah,
bit
you
of
may.
pop.
I had one of our buddies out there call me this morning that he smoked something. He says, you know, it wasn't rated for that. I said, no, it wasn't rated for that, was it? So you got to watch that rating. So yeah, it's a great point that Chris just made. You might want to put some tape on them or something, just to, whatever is your low current or low side marker. I'd get that sucker and wrap them up pretty good. That could be a unpleasant surprise. Now the SR752s are 1,000 amp max. So for like your K-base stuff, 60 amps, anything like that, man, they've got a little bit bigger aperture now, so I can get around a little bit bigger size conductors. Okay. So and also I've got that higher rating on them. So the 752s can be very convenient for you, especially where I really love them. If I got a CT can right there beside, okay, and I got that CT can, usually they just have that one big conductor run through that CT can. Man, I can slap those on there, boom, 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 and hit the button. So I really like them for that. Then, of course, we have primary now. So we're talking about primary stuff. So we're talking the Flex Probe. And as Chris put it earlier, it is one of our most flexible probes. So I like that. Yeah, so now he's rolling his eyes and shaking his head. That's fine. So,
It's a great pun.
It was. He didn't mean to say it, but it was pretty bad earlier today. So, but it is actually, because think about this. You can use this in a pad mount. You can also use it for overhead. So you can use this both in pad mounts, getting around conductors, and overheads. I mean, honestly, to what Chris said, no pun intended, but it makes it awesome to think that I can have a CT, but it's not a solid wound CT that I can't wrap around anything. Instead, I can take this one as a CT and wrap it around things. Now, of course, we have to do a little bit less accuracy than we would like sometimes. And you got to kind of watch the orientation of it and everything when you're putting it in there. But to think what it can do, I can start wrapping it around things, a CT that I can wrap around stuff. It is actually pretty flexible and cool. So you can take that thing, you just got to make sure that you get it oriented correctly. We're going to go over that all in here in a minute. But remember, I can use this, as long as it's less than 600 volt, I can use it in a pad mount or overhead. Okay. Now, primary, when you get into over 600 volts on the current probe, and you're going to need to use the HighVolt Probe when you get up into the higher stuff. You can see the rating on that. It is 250 kV. Face to ground, 433 face to face. So I'm telling you right now, obviously you can get in some pretty serious stuff with this. One of the biggest uses is substations, of course. So everybody uses them as subs. They mount on the end of an extendo stick to get to the overhead CTs. And if they were overhead and over 600 volt, you couldn't use the flexes, so you would have to go with this. Okay, so anything over 600 volt, when you're trying to measure the current, you're going to need to go with this. Okay, so and it is. It's very flexible as far as it's got fiber optic. We're going to talk about that here in a minute. You can have fiber optic, coax connections. We'll talk about that here in a minute. But anybody that's been out there testing any overhead CTs has seen one. And then this is this is our VP600. This is for the lower voltage PT testing. Okay, so you can see it's rated for less than 600 volts, and we're going to demo that here in a minute. All right. Just one step back. Oh, I'm too close. I'm sorry. My bad. What were they getting to see before? Just like from here down?
They're cutting off here.
You're cut off right there?
Yeah.
Well, then my head didn't look so big, so that might have been good.
Yeah.
Okay. All right, so so the VP600 is used for our lower voltage PT testing. Okay, and we can demonstrate that here on the bench here in a second. We're going to do that. Then if you have higher than the 600 volt for the high voltage PT testing, then you would use our high voltage probe here, our 8016.
Our shepherd's hook. That's what I always call it.
Ah, the old shepherd's hook. Okay. So anyway, if you've seen these in action, that's just, once again, goes on the end of an extendo. Use them in substations and primarily because most people, a lot of people aren't testing those PTs out there. So, but if you are going to test them and if you're over 600 volts, this is what you would use. Okay.
When I've traveled outside the states, PT testing is more prominent, especially in the Caribbean. Parts of South America, they seem to test a lot of their PTs that way, and I was actually part of that when we used that. So I've gained a lot of respect for the probe. I think it works well.
Oh, good.
Yeah.
Good. I haven't used it that many times. I've used it a few times. I'll be honest, I haven't used it. So here we have a meter with no test switch. So in this case, we would, you're going to have to use some other, pick up that secondary current. I got to figure out a way to pick up that secondary current somehow, right? So and of course the voltages as well, because I don't have any connections at a test switch right there. So the voltages aren't that bad because I got alligator clips. I can just get right there on my terminals and I can connect up. My voltages aren't the question. It's what do I do about my currents? I can't use duct bills anymore. I don't have a test switch. What am I going to do to pick up my secondary currents? That's where all these other probes that we're going to show you this morning come into effect, because literally right now, if I didn't have a test switch and all I had was duct bills, I'd be dead in the water. Okay, I got to have something else to pick up the secondary current. Or right now, I'm going to get too close again. I can't test them. Now, normally you're quite vocal, Jarrett, so you would just tell me, back up, get back, stupid, or something like that. So you can just tell me if I do that. All right. Okay, so we want to look at some stuff?
Yeah. So, if you don't have a test switch, what we recommend is using the MN114s or the MN375s. And we're going to switch over to John as he hooks up his MN114s, and we're going to pretend, everybody, we're going to pretend that no test switch is there. So let's make the assumption.
Right. So this is really not here, the test switch in the middle, okay? So if I didn't have that test switch there, I would just come in with my alligator clips and I can just grab onto the terminals where my wires are connected for my voltages, and that's not that big a deal, but it's what do I do about my currents?
And John can actually move his voltage clips up to the top of the meter base. Notice that you've got clips up at the top. You can actually move it up there. I'm referring to the actual socket.
Oh, gotcha.
The socket, yeah.
Oh, gotcha.
So you can clip onto the socket of the base, and then from the conductors coming out of the CT secondary up to the meter, you can clamp around there.
Right. So, like we said, the voltages are pretty simple. I would just use my alligator clips. What I've done is, and I've got a secondary set. I've got two sets of probe connections here on the back of my my 3 series, okay, that I'm using here today. I have this on all the Powermetrix equipment, and by having that second probe set available, it allows me to use a second set of probes besides my primaries. So here, having these two connections allows me now to be able to use a second set of probes where I don't have a test switch. So that's what I've done. I've got one set of probes I've connected here, are my primary probes over here, which are my flexes, A, B, and C over here. Then I've connected up a second set of probes here, and that's here, my MN114s. And you see my MN114s here. You can see what they look. We were talking about just the same as in the picture. These are rated. You can see the arrow, because remember, anything you measure current with has to be directional because current's directional. And so my current's coming up through that shunt blade and going up into the meter, right? So I know my current's going up, so I point the arrow up and I just put it on like this. Okay, so that's how I would put. So now I'm picking up my secondary current A, B, and C right here. I could come down here and get my wire coming in through the bottom of that shunt. It's either way I want to do it. As long as I'm getting around that wire that's bringing my current back up to the meter, and it's on the secondary side coming from the CTs. It's coming off the secondary side of the CTs. I'm good. I just want to get a picture of that secondary current. So I'm going, like I said, A, B, and C with those. A, B, C, and neutral with my alligator clips to get my voltage. And then I've got my pickup, like always. So now I'm going to go ahead and let me hit, I'll do retest. I'm going to previous out of here. What I'm going to do is I'm going to do a CT ratio test where I'm going to compare these secondary currents with those primaries over there, and we're going to see how close it is to 200 to 5. Okay? So I am going to, let's see, I'm going to check. Oop, I'm going to check. Can you see that? Up. Cool.
To your right.
To my right. Got it.
And we slipped up and totally forgot about a camera on
No
the
problem.
3 series.
We can roll, baby. So I'm going to check that double wrap box right there. You can see I checked the double wrap right there, because if you look over there, I do have my flexes double wrapped. And then I'm just going to hit my start button. Is that good there, Jared?
You can go up into your right there.
Perfect. Okay, so it's always showing me that color diagram, right? Where it's showing me, hey, this is what this is how you should make your connections, and we know we're good there. So now we're just going to go from top to bottom, A, B, and C phases, like we always do. Now I'll tell you what we ran into a little while ago. Cool. So we got to pass on all three, right? And you can see it's pretty tight on those MN114s. You can see at 0.06, 0.95. So we like those numbers, those low numbers like that. I will say that if you anything that we run into or anything that I run into in the field, I want to pass along what little bit I got in my pea brain. So I will tell you that when we were first doing this test, we had to watch with those MN114s of getting a phase angle error, of getting some interference from other ones. So you got to remember, when you start cramming anything that's picking up current, and I start cramming it around something, but I'm touching other things on there, that I can tend to pick stuff up. And unfortunately, it's the nature of all of our equipment out there. If there's not anything to keep it from picking that current up, it's going to pick it up and think there might be an issue. Okay, it might think we've got one wire run over to the wrong phase or whatever. So it's saying that's too much for me to accept and say that, no, I consider that a good test. This is something you should look at or something you should consider. And the phase angle error is telling us, now we know when it gets super bad, when we put one in backwards, that it's going to go all the way to the point where it says it's 180 degrees. And that is definitely a problem. But we're talking about in between there. And honestly, you know, the machines and I'm just a field guy, I don't field guy. For me, they're a little bit too sensitive on the phase angle error, but Chris is tired of hearing me talk about it, so I'm not going to talk about it anymore. But if that's the issue, you may have to move your MN114 around a little bit like we did, and we moved it a little bit, and now it seems to be working fine. Okay, but sometimes remember, with these current probes, positional is very key. Okay, the positional is key. Remember on our flexes, the center of that flex is the most accurate. If you move within that, inside that flex, though, it can get worse. So positioning is definitely important when we're trying to measure our currents. Okay? So it looks like we got a pass on all those, so everything looked okay. So that's using the MN114s right there. Okay? All right. And then we wanted to show some other ones, right?
Yeah, so what happens if I have, okay, I've got no test switch, but I still got to clamp around, but also an extended range CT. So with an extended range CT, I could have a little more current than 10 amps there, right?
Yes, Chris is exactly right, because remember we've talked about this in previous webinars. Now with these extended range, see with these rating factors of 3 and 4, what does that do to us on the secondary side of that transformer now? Now I can go from 10 to 15 to 20, yes. Right? So when I have 3, now I'm up to 15. When I go 4, rating factor of 4, I'm up to 20 amps. Remember what we showed the ratings on those those probes earlier. They were 10 amps. Okay? So what you have to do then is you have to bump up and go to the 353s, which are rated 200 amps if you're going to use them on extended range CT. So if they have rating factors of 3 or 4, the 10 amp probe is not going to work anymore. That's a great point, Chris.
So the nice thing about 353, you get versatility from 0 to 200 amps, but usually you lose a little bit of accuracy. So the smaller the range, the more accurate you can keep that probe at. That's why the MN114s are a fantastic probe, 0 to 10 amps. But if you've got a little bit more current there, you can use the 353, but you may sacrifice a little bit of accuracy to get around to measure that lower end of the curve on the probe.
Right.
So what about if I had a meter with underground CTs that's pretty good distance away, like 100 feet away?
Okay, so we've got a meter with underground CTs. So this means, remember, the reason you put underground there is if they were overhead, we would know immediately what we had to use, right? You're going to have to use, no, not necessarily if you have overhead. If it's overhead less than 600 volts or less, we could use a flex or a HighVolt probe. But if it's overhead and it's over 600 volts, we would have to use the HighVolt probe. Okay? So in this case, since he said underground CTs, then I'm going to say he's probably going to be using flexes. And if he's using flexes, he's going to need extension cables, right, to get out there to it. So we've got 50-foot extension cables. So usually what guys do out there is they'll buy a set of 3 of those from us. and then that way they can mix and match them. You know, they could get all 3 phases out 50 feet, you know, or if they needed to go out 150 feet, they could just use 3 of them all together on 1 phase. So typically what guys do is they'll buy a set of 3 of those, like I said, and mix and match them to get where they need to get to on the distance.
Mm-hmm. And the nice thing about our extension cables, they interconnect. So you can get 4 50-foot to get 200 feet if you need be.
Yes.
Okay, so let's say I don't have those extension cables. Is there an alternative method I can test those CTs?
No, I'm dead in the water. Next. All right. No, you remember those cool MN114s that Chris showed just a minute ago? These right here that we just looked at. I can actually take these MN114s. If I got over here on A phase, I can actually connect and get on one of these secondaries right here. And get on there like that if I wanted to. Okay? So I can get right on here because remember, to do a ratio test, now I can't do burden because I don't have duct bills to put the burden on there, but I can do a ratio test all day long because when I'm doing a ratio test, remember, I'm just comparing my primary current right here and I'm just comparing that to my secondary current right here. And that's all I need. I just need to read my primary current and my secondary current. So this is very similar to when you're doing a benchtop test on a CT. Okay, these people are going, man, how are you going to be able to test that thing? It's so many volts. I don't worry about the volts, right? I'm just worried about secondary current and primary current. So I can put a drive cable through that CT on top of that desk, and I can sit there and I can run that primary through it and measure my secondary. I'm not connected into the system, so the voltage doesn't affect me. So in the same case here, I can just get on here. All I need is my secondary current and my primary current, and I'll do a ratio, and I'll see how close they are to 200 to 5s. Okay, because when I was at Dayton Power and Light that time, you probably heard that story. It was a 15 kV or 25 kV rack. It had CTs and PTs on it. Got hit by lightning. And they had it on a big rolling rack in there. And they were saying, I said, well, you going to do it? And they said, throw them away. I said, well, why? And they said, well, you know, it got hit by lightning. I said, well, have you measured them? They said, no. So I took the 7 series and I sat there and hooked the drive cable through it. And I just ran a test. All I needed to look at was primary current and secondary. Of course, I can't hook into 25 kV or 15 kV. It's going to smoke my machine.
Yeah.
But I'm not interested in that. I'm just current and current, man. I'm just primary and secondary current. And right here, all I am is primary and secondary current. And I can do a ratio on that. Now remember, I can't induce the burden on it because I don't have the duct bill to do that. I'm purely measuring right here. I can't drive anything. The duct bill for Powermetrix is used not only to measure, but also to drive current. That's why we have the in and out flow with it, the black and white in and out flow. So I can drive the current with the duct bill, and I can also put burden on there. I can in this case. I'm just measuring primary and secondary. But I could do it this way, and I don't care how far away it is, right? I don't care how far away it is, as long as I can get on that primary and I can get on this secondary right here.
Yeah, so as long as we have access to the cabinet, we can clip around it, around both the primary and secondary, and get a good ratio test.
Absolutely, and there are a lot of people that do this because it's a great solution if you think about it, than having to drag all that stuff out there and then drag and put all that stuff back. Yeah. And so this way you could just do it right there if you're just looking for a ratio on that CT.
So the 2 cons I'll say of this is, again, you lose your burden.
Mm-hmm.
You cannot do a burden add test.
Right.
And you're not you're losing the circuit between the meter and the CT. You're kind of shortening that circuit, I guess.
Yes.
Yeah. So you're not seeing that. If there is a secondary drop from the meter to the CT, you won't be able to see that because you're right at the CT now.
That's true. I've cut out that whole length that we always concern ourselves with when we talk about, you know, putting too much burden on a CT. We talk about it could be too long a length of too small a wire, or it could be a connection or something like that. So you won't get the measure of all that long length out there, but it also gives you you can do a ratio on that CT and feel pretty good about it, unless you would have a skint wire or something between here and there.
Right. What about overhead CTs?
We just said this earlier. I got 2 options, right?
Mm-hmm.
If it's less than 600 volts or less, I can do a flex and go up there. Professor Ray Gore has absolutely done that because he's told me about it. So he's definitely used flex probes for overhead stuff before, but that was 600 volts or less. But if it's over 600 volts, then that puts you into that HighVolt probe, and you have to use our HighVolt probe. Okay.
Yeah, I want to make sure that there's no confusion that you can use the high voltage probe for overhead low voltage, overhead high voltage, and you can actually use a high voltage probe for a pad mount.
Yes, I've used it in pad mounts. Yeah, and some folks that have used it in pad mounts, and where it has come into effect that I've seen out in the field too is the whole 480 volt thing. So they don't want to get up in there, so they'll have it on the end of an extendo, right? They'll have the probe on the end of the extendo so that they can stand out here and do it, and they don't have to put on their moon suits for the whole process. They have to go in there to make their initial connections, you know, but once they get back out of there, they can stand out here and get the moon suit off when it's 98, and they can sit there and use that extendo.
What about if it's over 600 volts? High voltage.
High voltage, you got to use the HighVolt probes. Okay, you got to use our high voltage probe and our high voltage current probe anytime you get over 600 volts. Okay, so in this case, the HighVolt current probe you see right here, which is our 8016. And by the way, it's if you notice the difference in the numbers, it's an 8016-3 now. It's actually got a little higher rating than we had previously on our high voltage probe. So our high voltage current probe now has a higher rating. And so with that higher rating now, we're like we said, we're up to 433 kV face-to-face. So our 250 kV face-to-ground. So you can, so with that higher rating now, it's helped with some of the applications we've had out in the field. They've actually needed that higher rating. And also, it also came into account for overseas. So, so we were glad to get the higher rating on it.
And what if I have overhead CTs high voltage, but I had a nice distance between the meter and the CT?
So we got within, let me grab my storage area right here. I'll grab my HighVolt probe. So in the HighVolt probe, with our HighVolt probe, you know that you have the head unit, and this is the unit that goes on the end of the extendo. It goes around the conductors. So yeah, you would put it in this case for here. I would put it around there, right? So I would put it around here to pick up my primary current, okay? And then the connection between the head and this base unit,
The receiver.
The base unit or the receiver, and you would you connect the two of them to communicate with this fiber optic. Okay, so you have a couple of choices here though. So I can get an extension of the fiber optic, so I can get a longer fiber optic cable, okay, or I can go with a coax cable. The only difference between those two is the losses that I'm going to experience. You don't experience losses in the fiber optic, okay. So there's going to be a difference between the two. I can run this fiber optic as long as I want to. I won't have any losses. With the coax, I might. So if you do want to go with the coax, it is cheaper. Okay, so there's always pluses and minuses, right? The coax is cheaper. You're going to see some losses with it, though. So we need to make sure if you do decide to go coax, always give us your coax cable to calibrate your HighVolt probe. Because with those losses, we're going to need to calculate those in when we get ready to calibrate your test probe, okay? Mm-hmm. So you can go it's more expensive, but you don't have any losses with the fiber. It's less expensive, but you will experience some losses with a longer coax.
Yeah,
okay?
to be clear, you should not experience any loss with coax under 100 feet. But if you do go over 100 feet, you will start seeing a signal lost. And like John mentioned, we do want to make sure that you get that unit in, calibrate the cable along with the probe.
Exactly.
And you don't have that problem with fiber. However, John's correct. If you get the fiber, you can go 200, 300 feet without a signal loss, but it's going to cost you about twice as much compared to coax.
So there's always the pluses and minuses, right? So, so you've seen the HighVolt probe. I'll just talk about them real quick. So the HighVolt probe we've talked about that you've got. I've got a line here. I want to be inside of here when I'm up there around my conductors. So I want to bottom the conductors out. This goes on the end of the extendo. You always face the label towards the load to get its polarity correct. Label towards the load. If you do that, the polarity will be correct. If you turn it the other way, it's going to give you polarity reversal. Okay. Make sure when you turn on the buttons and everything, you get your green light on there. And once you get your green light, you're okay on it. You press the button on the receiver or base unit, and then also on the head unit. Okay. So if you'll press that. So that's our HighVolt current probe. Then we've got our, we mentioned it. Let me get it out of my drawer here. So Chris mentioned a VP600. So the VP600 is used to test 600 volt or less, right? PTs. So when we make the connections, this just connects in. These are the standard connections you can see right here on the ends of these probes. It's our same pinned connectors that we use, and they're milled so that once you turn it, you'll feel it drop down, and then you can tighten it down to line the pins up correctly. And I know that's a silly little thing, but I've also seen guys just grab and start twisting, turning, trying to cram them in there. You're going to feel it drop in, because otherwise you're not lining the pins up, and you're going to jack that connector up, okay? So you'll feel it, just turn it. When you feel it drop in, then go ahead and tighten it up. So that's what you'll do right here with your 3 phases. I'll just connect these 3 phases right here, right? Then I would have this, and then I would just come up here, and I would go very similar connection that I make on the CTs, all right? I'm going to come over here first, and since these are tied together, I'm just going to make my initial connection over here for my returns. And then I would just come over here on my H1s on my high side, right? And I would just go A, B, and C. So I connect on my high sides, right? Because we're dealing with primary here. It is 600 volts or less, but it's still primary for us. So then I would come over here on my H1 and H2. So I just got on one of my H2s because they're tied together. And then I got H1, H2, H2. I got right here, right? Red, yellow, blue. HHH. So I'm staying on the high side on that, okay? So that is the, it's not the shepherd's hook. That's for over 600 volts. This would be if it was 600 volts or less, you could use the VP600 to test your PTs, okay? And then we'll look at some of these other probes real quick. These are the 752s that Chris had right earlier that he showed you. Remember, once again, always look for the arrows. There's going to be an arrow in any of these things, and there's an arrow in here. And for us, it goes in the direction of the current or towards the load. So on this 16 right here, you would come over here on this 16, and I would just, my current's coming right there, so I would just connect that right there. Okay? So I would connect that on that 16S, and this is rated up to 1,000 amps, so I'm fine on that. And you can see, you can get into some pretty decent sized stuff, okay, with the size of that hole there. So like I said, and when I've got a CT can right next to my transformer, and I've got those one big conductor run through there, man, this is sweet. I just drop her on there, okay? So this is the 752. Now, to what Chris said earlier, so you can see they're both, remember, I'm always big on putting the tape on there so I know what phase I've got in my hand at any time, right? So I've always got this phase coloring on my probes and then on the probe adapter cable, so I always know where I'm connecting up. So which one of these would be a 375 and which one of these would be a 353?
Yeah. Good question.
Yeah, you would. So, but if you look right here, this is a 375. And this is a 353. So this is 200 amp rated, and this is 10 amp rated. Okay, so just remember, they are exactly the same size and everything, so make sure you make some mark on there to differentiate for you, okay? As you can see, both the same size. Then last but not least are, of course, the flexes. And I did want to mention something in here that if you... and you have to use one of these if you have a situation where they're running 2 conductors through the same CT. Okay, so if you're running 2 conductors through the same CT, what you would have is you're going to have to figure 8. And what's great about the Powermetrix equipment is it actually shows on that color diagram. Remember, we show a color diagram before we test the meter, and we show a color diagram before we test the CTs. And before it gets ready to test the CTs, it will show you how to make those connections with these probes up there. And it will literally show you a figure 8 like this. Okay? So this is what we're talking about when we're talking about figure 8ing. So why do you figure 8 the flex like that? Because remember, this is directional. There's an arrow on here. And now that I've done this, my arrow goes this way, and this way, this way. So if you think about it, I can have, if I've got A, B, let me do it this way so y'all can see it. I got A, B, and C phase. Well, I got it right like this. If I have it like this, now think about it. If I do that, I can run that same conductor on B phase. I can take them and run it both through. I can just use two flexes. I can put one up here like this, and I can put one down here like this. And so I have B phase running through both of those CTs, but one will be running one way and one the other, so they'll cancel out, and it's using it as a reference. So you will need to figure 8 them if you have that application where you've run multiple conductors through there, trying to save some money on a CT. But what it means is you're going to have to figure 8 that to pull it off. You can't set up another setting where you can add more CTs in there. You can do the more CTs on it if you want to do it that way in certain ones. So make sure you look at the service that you're setting up. Sometimes you can set it up for more than one CT and you'll just use more than one of these. But if it tells you to figure 8 it, then this is what it's talking about right here. And you can get the idea now. I've got arrow going one way this way and arrow going that way on the bottom. So I can literally have another one under here around that same B phase here. And this will go one way, that'll go one way, and that's great. And these two will cancel out on B phase.
Yeah, so this using that figure 8 application is fantastic for testing those non-Blondell 5S meters that have 2 CTs. And I've seen it both a Y and a delta. Also, it's a figure 8 is also great for testing a 3S meter with a CT because the conductors go in the opposite direction.
That's
to
right.
sum. That's an interesting thing about it. You look at negative and negative and actually sums together. That's why you have to do the figure 8 to actually grab the 2 phases so they don't cancel out when you do your ratio test.
That's right. So you can see that using all of these secondary probes and some primary probes can really help you out in the field if you've got distances you got to try and conquer out there. If you've got a where they run multiple conductors through, you're going to need to be able to figure 8 and use those flexes for that. But you've got these secondary and even some primary clamp-ons that are great. If you have to go in and test a whole bunch of these, if you're testing a whole lot of K bases, or you got to go out there and test a whole bunch of 16S in the field, man, those 752s are so easy to just pop on there, man. They're really, really easy to pop on there. So, and we know just as a general rule that clamp-ons are going to tend to be more accurate than our flexes. It's just because of the nature of them. They can put a little bit more insulation on the outside to get less interference than you do on those flexes, okay? So any questions? Anybody got any questions on probes today? You can see that by having those 2 probe channels on the Powermetrix equipment, that allows us to use two probes, okay, on there. So if you're going to do and Chris has got up on the screen now, you can even do you can measure the burden on a PT. And if you did that, it's kind of the same concept here. I got MN114s or MN375s. They're both 10 amp rated. So that's just for me to be able, you can see the connections there. That would be for me to come up over here and pick up my currents if I want to pick up and measure the burden on there. I've just got to get those clamp-ons and get them up there to be able to measure that burden.
Yeah, so in this case, in this application, for a 3, if you had a 3 series, you can actually, like John mentioned, you can actually see the resistance or the voltage drop using a clamp on, which is kind of unusual. People don't think about, oh, I got to put a clamp on around the potentials coming in. Yeah, we use that to actually see how much resistance is there on the PT. So you will need clamp on probes to do that. And you can do that either with the MN114s or the 375s.
And Chris is exactly right. That added feature of this whole burden measurement that you can do with the 3 series, it applies to PTs and CTs. So we don't talk about that enough on the PTs, but it's only because people don't test PTs as much here in the U.S. But that is a definite feature of it is you can also measure the burden on the PTs because it affects them just like it does affect the CTs. So but we just don't talk about it much because there's not that many people are testing it. But you would use those small probes to be able to pull that off as well. So you can be a lot more flexible in testing, you can see. I mean, you can have a long distance, and I just want to see a ratio test. I don't have to start unrolling, 200 feet of wired stuff. I can just make the connections right there using those MN114s. You saw that. You also saw the figure 8ing and being able to do that. So because, I say this all the time to the guys out in the field. They sure as heck didn't think about us when they built that pole, did they? When they put that installation in. They do not think about the folks that have to test it. Because if they would have just thought about us a little bit, they could have made it a whole lot easier on us, couldn't it? So, but it usually isn't. So that's why you need these, because we know we're going to run into squirrely stuff out there. We're going to run into things that don't fit the normal mold. So we need some of these additional probes right here, and having that second probe channel that we can get on allows us to do that. So we can definitely still test stuff, even if they throw us those curve balls, just adding a few of these additional probes in there. So if you got any questions about any of them, just give us a holler here in Knox Vegas. Don't know yet what we're going to be doing next week, but I just want to tell everybody thank you again. We really appreciate y'all's support. And man, I really appreciate folks just, I'll be talking to somebody and they'll mention about watching this and everything. So I try and...
Go vote.
Yeah, go vote. And so I don't say it enough. I don't I do let these guys know every once in a while. Like if I get an email or something, but I don't tell them enough the job they're doing, man, is being appreciated out there. And we appreciate that you appreciate it. So thank y'all. Thank y'all a lot. Have a great day, and go vote. God bless. See y'all next week.